Welcome everyone to Yes, I Can. Tap into your students' passion through coding and ECC. Thank you for joining us. We have a lot to cover today. So we're going to get started and introduce our presenters. First is Robin Lowell. She's the accessibility advocate for I2E. And also with I2E, Beth Dudycha, and she is the senior manager of content development. If you've been to CodeJumper webinars in the past, you may have heard one or both of them previously talk about CodeJumper. So let's get to our learning objectives today. So we will be discussing computer science education for younger students. We're going to learn new ways to engage with CodeJumper using the puzzles. These are fun puzzles, very enjoyable. We're going to explore how CodeJumper can engage students with the expanded core curriculum in new and novel ways. We'll understand the importance of all students learning about computer science careers. You know, not everyone's going to end up in that career field, but it's certainly a good thing to experience it and explore it because you just never know. Our challenges today, see if any of these things are familiar to you. Most classroom teachers, and maybe you, don't have sufficient experience with coding to feel comfortable and confident introducing computer science skills to your students. There's some teachers that may be working with just one student at a time, and you require more independent learning activities in coding. If that's the case, we're going to help you understand how you can do that. Teachers need new and novel ways to engage their students in the expanded core curriculum. And students may not see their own future career potential in computer science. Again, very important for them, even if they don't end up in the field, to feel like they can do it and they're not held back because of blindness or disability. So let's get started. I'm going to turn this over to Robin to begin the presentation today.
Great, thank you. So I'm going to go ahead and share my screen. Let's see. All right. Great. Well, welcome everybody. Yes, as Paul said, I'm Robin, and I was a TVI in all sorts of different settings. So I have a lot of experience working with students in different areas of academics and expanded core. And my co-presenter is Beth Dudycha.
Hi. Beth Dudycha, and I'm super excited to talk to you about computer science today. Yeah, Robin, go for it. Go for it.
So Robin is driving, so Beth's gonna tell me when to move slides. So yeah, so we'll get our flow rhythm. So Beth, take it away.
It's all good. So on the screen right now is a statement that says computer science is vocational, but it's crossed off. And then underneath is a statement that says computer science is foundational. And this is so true. This is really part of why we wanted to kick off with this, because computer science is something that is embedded into almost every job imaginable in the future, not just jobs for the sake of it being a job, but part of the fabric that's woven into almost every area of life these days. Go ahead and move forward. Computer science, and this is a quote from Jeanette Wing, thinking like a computer scientist. And she says, computational thinking is the thought process that one uses to formulate a problem and to express its solution in such a way that a computer, human or machine, can effectively carry out. This term computational thinking is not exclusive to computer science. We use it a lot in math. We talk about it in other areas of life as well. It was coined in 1980 by a mathematician and computer scientist named Seymour Papert. I'm not quite sure about the pronunciation there, so I apologize. Over time, it's been broken down into 4 general components: decomposition, pattern recognition, abstraction, and algorithmic thinking. So decomposition, we talk a lot in computer science terms, but it is part of this computational thinking. It's just the ability to break a larger problem down into smaller parts. Now, if you're not familiar, and some of our audience is not super familiar with teaching computer science with their students, that's okay. All of these things I'm going to talk about are things that are, if you think of them, they're just a daily part of our life, and we just put a fancy word on it. So part of teaching computer science is understanding the vocabulary. So I meant to say that a minute ago, but decomposition is one of the key components in computer science. It's something we come back to a lot. What is the problem? And then how can we break it down into smaller parts? Pattern recognition. Hey, we talk about that all the time in different elements of our classrooms. When you observe patterns and similarities and try and weave them together to solve problems. Abstraction is when you identify what the patterns you see and focus on just the important information. So you might see a full pattern somehow, but there's only part of it that really relates to solving the problem. And algorithmic thinking, when you develop a step-by-step plan, or you develop step-by-step rules to solve a problem. There is no right way to do something. And in computing, this is also true. It's a science. It's a lot of trial and error. Coding and programming and computer science in general is very similar to other science subjects in that a lot of times we try something and see if it works. And we fail 99% of the time. And then we figure out the one that works and we run with it. And then we get to the next problem. Lots of trial and error. And the physical nature of the work engages all students with their mind and their body to create a personally meaningful end product. That is thinking like a computer scientist, finding meaning in it, finding some importance in it. And that's where we think the hook could be for you, especially as teachers who might not be familiar or might be intimidated by teaching computer science. There is meaning to it. And if you can loop into that, it will sometimes make it a little easier for you to feel more comfortable in trying and failing, because a lot of us will try something, screw it up, try it again. That's just part of the way it goes. Along that line, we have a great meter on the next slide.
Oh, Beth, can I add just one thing?
Yes, please.
We'll talk more in depth about the ECC and how this fits in, but thinking about all the different areas we have in expanded core, and this is what we're doing. We're breaking things down. We're taking these daunting tasks and making them manageable, that in ways our students can understand them across the ECC. So we'll dig in later about that. I just wanted to make that connection that the ECC is really, to me, I find so much of it to be like computer science and what we're teaching. There are whole new worlds for across computer science, coding, and expanded core, but we'll get into that. All right. So I gotta find my mouse and I'll go to our next slide. There we go.
Yes, I can. This is not only a phrase we want students to embrace, but we want teachers to embrace it as well. Yes, I can. Computer science is not actually so daunting as it seems at the start. And if you're not familiar with it, that's okay. Just have the mindset that you're going to give it a try. So on the screen, there's kind of a half circle divided into 3 parts, and then a little arrow that could flip like a meter. And on it says I can't, and it's in green. In the middle, it says I'll try. So the arrow could flip to the middle in the blue area, or it could flip to the right in kind of an orange area that says I will. This is a great way to help engage kids too when they're trying new things. It is intimidating to start something new, but being mindful about how they are thinking about their own abilities. And we want all students to see themselves as computer scientists. We want all students to engage in a way and know that they can do these tasks, they can understand these concepts, especially if they're introduced at a younger grade. So on the slide, it says, excuse me, metacognitive thinking about your own abilities, creating a mindset in the younger grades. This is critical. If we start young and we keep teaching kids at a young age that this is an option for them, this is within their grasp, And we can start to turn that meter from I can't, at least to I'll try, and hopefully I will. We want to engage with activities that create excitement, and we want students to see themselves as computer scientists. And that starts young, and it can start in all elements. I mean, the ECC is just one example, but my goodness, there are so many things in there that encompass almost all areas of life. And so to make the connection to computer science with those things helps kids to see how embedded it is into our world. I think they kind of go hand in hand. We talked, Robin, you and I talked at one point about it going really well with the area of self-determination. That metacognition of I can do things, and these are the things I can do. And it sounds maybe simple, but it is so tricky sometimes with students to get them on board.
Absolutely. So just, yeah, thinking about self-determination real quick, that's understanding yourself and others, personal management, effective communication, decision-making and problem solving, all of that fits into this metacognitive experience of thinking about your thinking about your abilities and what that all means. All right, do I need to flip to the next slide?
Yes, please.
All right, there we go.
So what is out there for beginning coding? On the screen are just two screenshot examples. On the left is an image of Microbit, and on the right is an image of Scratch. Currently, there's a lot of good programs out there, but unfortunately, they're not accessible for students with visual impairments. So many of them use block coding, which is a highly visual way to understand coding. So it's used by dragging and dropping. You could think of them like sentences or sentence fragments, and they're often colored together. You can sort of see in the example in Scratch, they're actually both of them have colored blocks with that sentence fragment in them, and the student can drag them around and put them together and make sentences and make paragraphs and things out of these blocks of code, so to speak. And they fit together kind of like a jigsaw puzzle, but that's not easy to do for all students. It often requires a mouse. It's highly visual, as I said before, and it's just not, for a lot of students, it doesn't lend themselves to understanding all of the elements of computer science as well. So they don't end up getting the full experience of how exciting it can be to create code and the empowerment and the creativity that can come with it. Sometimes these programs can sort of squash that or not. You don't get to that really exciting part until later on some of these. But Robin, was there anything else you wanted to say about some of the other options out there?
No, I think it just ties into the yes, I can. So we need to ensure that our students are getting an experience that says from the beginning, oh, this is something I can do, and not this is something I can't do at this time. That's all. All right. So then we have our poll question. So I'll turn that over to Paul.
All right, thanks, Robin. So what we'd like you to do for this question, we want you to rank the importance of all students engaging in STEM activities on a scale of 1 to 5, and 1 is least important, 5 is most important. But just place your check mark in any one of those, 1 through 5, to designate how important you think it is for all students to engage in these activities. And while you're doing that, if you have any questions for Robin or for Beth, go ahead and place those in the chat.
All right, well, let us know if there's any questions that come up during this webinar. We'd be happy to answer them when we pause again for a poll question. 64% of our audience participated in the poll, so keep filling this out. I'm really loving the results so far. For the question, rank the importance of all students engaging in STEM activities on a scale of 1 to 5, 1 being the least important and 5 being the most important. 62% said 5, 24% said 4, 5% said 3, and we keep that going towards 1. So 5% voted for 1 and 2 respectively. So lots of people agreed that it's a 5 or a 4. Those were our 2 highest categories. So I'm going to end that poll and hand it back over to our presenters.
Thank you. All right. So we talked about CodeJumper in the abstract. Now let's dive in and see it in the concrete. And so Beth's going to start out with our puzzles.
All right, so those of you who are not familiar with CodeJumper, just hang tight. You're going to get a chance to experience it in just a minute. Very briefly, we're going to go over it through one of these puzzles. But CodeJumper has an entire curriculum. It's an entire computer science curriculum, and it walks you through it. Even if you've never taught computer science before, don't worry. It is very easy to follow. And these puzzles are a little bit different. They're in addition to the curriculum, and they're intended to be potentially independent. And students could probably go through a lot of them independently, and they could play them over and over again. A lot of them are meant to be done repeatedly, and we all know doing some of those repeated tasks, first of all, sometimes builds engagement, and secondly, helps solidify some of the information they're trying to I'm at a loss for words.
Wire.
Yes, sorry. Anyway, so the puzzles that we currently have that you're getting kind of a sneak peek, because I think these are not yet published, but they will be very soon, are about a character named CJ. CJ is an alien life form, and each of these puzzles has a little story about CJ. We meet CJ when we explore the planet Jupiter. CJ gets a job, which we're going to talk about in just a minute. CJ learns about the water cycle. Where be the treasure? Quit diddling around, CJ. CJ's great send-off. CJ's day at the amusement park. And where does CJ go next? So each of these is a story, a puzzle. Some of them are more curricular, like the water cycle, and some of them are intended to just be fun to help solidify these content areas within computer science. So today we're going to show very quickly, we're not going to get to go in great depth about CodeJumper itself. We just want to show kind of a high level of how these puzzles could be used. CJ gets a job at a pizzeria. And Robin, do you want to she's switching her screen for a minute, and she's pulling up CodeJumper on her document camera. She's got the puzzle on the left side of the screen, where there's a picture of CJ, who is kind of a cross between maybe a raccoon and a cat. He's blue with orange tips on orange eyebrows, orange tip of tail, some stripes. And he, in this picture, is wearing a chef's hat and an apron with a pizza on it. There's a pizza crust in front, and there's some toppings being thrown around. He looks slightly maniacal, like he is really excited to have a job. And I bet just with that description, you can imagine he's got a job at a pizzeria. And so kids really have fun with this puzzle. At the top of the screen is the CodeJumper app that needs to be connected for CodeJumper to work and to be able to hear the sounds of CodeJumper as you're playing the puzzle. And then at the bottom are a whole bunch of pieces. And I think there's the hub. I think you'll have to scroll down. I forget exactly which pieces. Isn't it just the play pods?
Yeah, we're just using the play pods. I just have up on the screen right now, I have the hub, Oh, is it frozen? So my, there we go. I have a little technical glitch. Sorry about that. My camera froze.
That's okay. We allow those once in a while.
Right. Oh, there we go. Okay. I was
Oh, there we go.
moving
Now I
the
can see it.
camera and I wasn't moving. Okay. So I have, there we go. Because I was getting confused because the picture on the screen was not showing what was down here. So yeah, we just have the play pods and the hub. So the hub is where it begins. It's basically our Bluetooth speaker and the little computer part that attaches to your app on your device. And then right now I have 4 play pods sitting in front of there, which are mouse shaped with 2 dials. I have 2 dice, and I actually have the plugs, but I don't need those for this time. Okay, so that's what we have for CodeJumper. If in the chat, if you need a more in-depth description of each piece of CodeJumper, please let us know. Otherwise, we're going to go forward and just build it. But if you'd like a better description of each piece, happy to do that. And so, Beth, tell us about this amazing CJ puzzle.
Yeah, we're just going to go kind of high level, but in general, this puzzle, there is a menu of toppings, and each topping has an amount that it costs to add that topping to your pizza. And so Robin has a couple of dice over there. And so at the beginning of the puzzle, students will roll the dice and get a number, and that is how much money they have total for this round. Again, this is a puzzle that gets played over and over again. It has a lot of longevity to it because students like to create different puzzles with different things on it. Robin, looks like you rolled a 4 and a 1. Is that correct?
That is correct.
So you have $5 to spend. On the PDF that with the puzzle, there is a menu, and it lists out the toppings. The toppings are mozzarella cheese, which costs $1, potato chips, which costs $3, olives, which costs $2, gummy worms is $4, sprinkles is $2, pineapple, a little controversial on pizza sometimes, costs $3, pizza sauce is $1, and whipped cream is $1. These are maybe not typical pizza toppings that your students have actually tried, but they love making these sounds because we have sounds associated with them in CodeJumper. So Robin, let's pick a couple of toppings to make our pizza. It looks like you have 3 play pods out there. Do you think?
Yeah, I have 4, and I have more that we can do. I just have them sitting around. But first,
we only have $5, right?
We only have $5. So our pizza, you can either make a dessert pizza or we can make a savory pizza. But first thing in the app, I need to choose my sound set for pizza. So I go up to thread 1, which you can use a mouse or you can use all keyboard. And I'm going to select under the custom sounds, sound set pizzeria. Okay. So now the sounds that are going to go, that we're going to build, each line of code is going to be related to pizza. So we have $5. So do we want savory or sweet?
Let's do sweet.
Okay, let's do sweet. So I think we should put on a base of whipped cream on top of our base layer. So I like to say the hub is like our pizza crust, and then we layer it on top. So I have pizzeria in thread 1. So I'm going to take a play pod, insert it into thread 1 on the side of the hub. And I'm going to turn, first I'm going to turn my speed to 1, normal speed. So we need to find whipped cream. We can do this 2 ways. We can either read the code and it'll tell us the name of it if we aren't sure what the sound is, or we turn the sound dial. So let's listen to see what we can find. That doesn't sound like whipped cream. Ah, that sounds like whipped cream. But let me double check. So I press stop and play.
Thread 1 pizzeria. Play whipped cream normal speed.
Okay, we have
and
our
thread.
Sorry, we have our base layer of whipped cream. So we've spent $1. What's another thing you think we want to put on there?
Sprinkles.
Sprinkles. And how much is that going to cost us?
$2.
Okay, awesome. And I'm going to turn again my sound dial to see if I can find sprinkles. That doesn't sound like sprinkles. Nope. Oh, that sounded like it. This.
You're on fast.
Oh, so I better turn it to normal. Debug it. Okay, so I'm gonna press play and see how we have this. Okay, I have whipped cream and I have sprinkles. So now we've spent $3, which would be our last topping. You know what? I actually think potato chips would actually sound, oh, we have $3, yes.
Okay,
I think
now
potato chips or pineapple.
either one.
Pineapple, we'll go pineapple. As you think about it, does pineapple actually make a sound? So we had to be creative. So I'm going to turn. Oh, there's our pizza sauce. I'm going to turn. Nope. Nope. Nope.
That was potato chips.
Oh, I thought we were going to do pineapple.
You're right. You're right.
Oh, wait, pineapple. But you have to cut pineapple. So it's a sound of pineapple being cut. So now I'm going to press play again. All right, we just built ourselves a pizza that I actually think would be quite delicious, of whipped cream, sprinkles, and pineapple. And there's activities in here to do with your students, or they can do it independently and create a pizza store and ask people to build menus. And I'm going to scroll a little bit down on the PDF, and you can create a menu and write it down. You can do a partner extension and
Practice ordering.
Yes, that's a great skill. That's an independent living skill. Practicing ordering, how to use a menu, because I know even my own kids in high school, the thought of having to talk to somebody and order food for themselves is terrifying. So there's a lot of great skills here that we can do just in this one puzzle. And we have all of those will be available. Yes, it's going to be in Braille, it's going to have an auditory version, and it's going to have a PDF version of it. So it's going to be in all formats. Yeah, so there'll be an MP3, Braille, and a print PDF, large print PDF. So yeah, so we have all those. We're working on all of them. I'm so excited for them to be released. How about you, Beth?
Super excited. This is if you're not familiar with CodeJumper, it is an easy entry point to get kids just playing and having fun with it. And you will see all of these embedded skills in a lot of these puzzles.
Right. Okay, so now we've looked at the puzzles. So there's so much to cover. I know we're just doing really high level. Now let's really talk more deeply in the ECC. So we have our 9 areas, and to refresh everyone's memories, that's the assistive technology, careers, compensatory skills, independent living, orientation and mobility, recreation and leisure, self-determination, self-efficiency, and social interaction. And it's really fun of all the different ways that you can engage CodeJumper. I mean, anything you're doing in these 9 areas, but really focusing on CodeJumper, we're going to talk about some of those. But Paul, we have another poll question.
We definitely do. And this time, I believe this is a single choice question, even though you may want to pick several. We want to know, what is the most difficult area of the ECC to engage students in? Again, you may have several, but which one is the most difficult for you? We've listed them all: compensatory access, sensory efficiency, assistive technology, orientation and mobility, independent living, social interaction, recreation and leisure, career education, or self-determination. What is the most difficult area of the ECC to engage students in for you?
And we did receive a question earlier that I answered in the chat, but just to make sure we also share it with our whole audience, is the CodeJumper app for computer or tablet?
Well, yes, computer or tablet. It's available for Windows devices and Android devices. So any Windows tablet will work. And there's currently not yet the app for an iPad or Apple products. It's interesting looking at where all the numbers are going. This makes sense to me.
Yeah, it's a little all over the board. You had multiple different options to choose from, and we asked you to just to pick one. So top winners or top categories look like independent living is hard to teach, self-determination, social interaction, assistive technology, then goes down to more less popular choices like compensatory access, recreation and leisure, and then finally O&M. No one chose sensory efficiency. So thank you guys for taking that poll. Lots of different responses there.
Yeah.
We'll hand it back over to our presenters.
Awesome, thank you. All right, so moving forward, so let's talk a little bit about that. So CodeJumper in the ECC, how can we use it? And I think if you actually look at just using the curriculum and then the engagement in CodeJumper, there's a lot of skills that are naturally built into CodeJumper for the ECC, especially around careers and the social aspects and social interaction for sure, because the goal of CodeJumper is to be interactive, is to be working on things collaboratively with peers of whatever level of vision. And but we really started digging in, and actually Julie Hateman, who's on the call, and I had a nice long discussion about this, all these different ways that we could use CodeJumper. And so really thinking about it, let's start with orientation and mobility, where it overlaps with CodeJumper and computer science, thinking about those computational skills. Getting on the bus is an algorithm. You have to do the steps in a row. It's a sequence, it's an algorithm. You have to go through these things in order to make it work. If you don't, it won't work, because if you're not there at the right time, you're not even going to get started. Compensatory skills, organization, you have to keep yourself organized. And one thing I really love about that is like CodeJumper sits on the table and there's lots of pieces, so many opportunities to help a student organize their space around them so they know where everything is in a fun and novel way. Assistive technology, well, CJ is AT, and it gives our students opportunity to explore assistive technology in a way that can be really non-stigmatizing, because it's great for everyone. And then independent living skills, routines, and sequencing. So let's actually look at a program. So I created a program around independent living skills, and I thought about what I wanted to do. And our theme for today is food, if you haven't noticed. So what we are actually going to do is we're going to go through the algorithm. We're going to go through the sequencing and algorithm of how to make pasta. So I'm going to change my screen for a minute, and I'm going to go back to CodeJumper and look at what that would look like. So I'm going to make it big this time. Okay, so I have a sound set. And first I'm going to take out CodeJumper. I'm going to unbuild what we built last time. I'm going to change my sound set and my custom sounds to the sound set for making pasta. And so I found all these sounds on the web for free. And I thought, okay, how do we make pasta? So this is just a sequence. So I'm using just the play pods. So what's the first thing we have to do? Hey, Beth, what's the first thing you need to do when you're building when you're making pasta? What do you think? There's a whole bunch of different things, but what do you think the first would be?
I need a pot.
Yes.
And
okay.
that's the first step.
Yes. Okay. So we need to find the pot. So I'm going to turn my dial until I. No. That sounds like my kitchen. I'm digging through things, trying to find the right pot. So you have to find the pot. And I'm going to play the code so you can hear what the title of the sound is.
Thread 1 making pasta. Play find the pot normal speed. End thread.
So I found the pot. Okay, step 1, we got to find the pot. Whitney, I'll find out the website. I can't remember off the top of my head. I used a few different ones.
I just posted in their Audio Jungle because that's the one that I've used.
Yes, Audio Jungle is great. Okay, what's the next thing, Beth, do you think?
Fill it with water.
Fill it with water. Okay, let's see if we can find filling it with water. Yes.
Yep. Sounds like it.
So if you notice, some of these sounds are long, and that's intentional because I was thinking about it, and a lot of times we shorten the clips, but I wanted it to be that, no, these things actually take a long time. Filling the pot isn't done in 2 seconds. So I think a lot of times you would err towards going, oh, well, this is just reading how we're going to do it. But if we make it as long as it's going to be, I think it sets the expectation and it's accurate. So some of them are longer sounds, but I mean, obviously, in reality, it would even be longer than that. Okay, Beth, what's the next thing you got to do?
Well, then you'd have to put the pot over on the stove.
Right. Nope, that's water. You found the pot already. You filled it with water. We got to put the pot on the stove. Okay, we put our pot on the stove. Then what do we have to do?
We got to turn on the stove.
Correct. Nope. Nope. There we go. We just turned on our burner. Okay, so the next part is the hardest, because what is the hardest ever thing to do, Beth?
Watching a pot to see if it's gonna boil.
Right, a watch pot never boils. So yes, so this one is we're waiting for it to boil. We have to boil our water. So let's see if we can hear a sound of boiling. Nope. 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 Turned on the burner. Oh, it's not, it's hard, it's normal speed. It's kind of quiet, but this one's long because, as we know, a pot takes forever to boil, and it can be, you know, it can be frustrating. So here we go. It's still boiling. Okay, so now our water is boiling. Yay! So what do we have to do?
Let's see. Look at the time to figure out how long we need it to boil for.
What are we boiling though? Do we know what have we?
Oh, we didn't add the pasta. Yeah.
Yes. See, and that's a great natural debugging right there. Oh, great. We set the timer, but we haven't put anything in the pot yet. And I can verify I've done stuff like that. My fair. All right. I just plunked the pasta into the water. Okay. So then what? Then what were you saying before?
Then we set the timer.
When we set the timer. All right.
Oh, waiting is so hard.
Oh, look, the timer went off. So what do we do now? What's the last step?
To drain the pasta.
We have to drain
the water out.
Yes. Nope. Put the timer. Nope.
Oh.
Then we drain the pasta. So just for full transparency, Beth has never seen this sound set before. So this was all that processing and problem solving using your computational thinking skills on what the process would be. And there's lots of opportunity to debug, as we call in computer science, to find errors, because then I'm not going to run the code because there's a lot of long sounds in here, but you can run it with your students, and then you can then take all of each one and you can create a recipe for making pasta. Mm-hmm. And so we just created an algorithm, which is a really important computer science concept of how to make pasta. And so you can do this for anything, shoe tying, any skill that you can build into, daily skills of moving around the building, so, I mean, let your imagination go wild. I mean, in the chat, throw in ideas that you have. We'll look at those as we go. But if you have an idea of an algorithm you can build with your students, that would be a way to teach them a skill throw it in there and we can share that. All right, so that's an example of a program that we have built. And so now, but actually we have a poll question. Paul, over to you.
Thank you very much. Okay, so we want to know, when do you start engaging students in conversations about careers? Do you start in early elementary school, maybe late elementary school, middle school, or do you wait till high school? When do you start engaging students in conversations about careers? Early elementary, late elementary, middle school, or high school? And again, if you have any more questions, please place them in the chat, or if you want to answer the question Robin just asked, if you want to come up with ways that algorithms, things that would make good algorithms, place them in the chat. We saw one about a morning routine. Keep them coming.
All right, it looks like I'm having an issue with this last poll. People just saw it shared and not necessarily, we're going to try this, so apologies. And we did have a question, if you have the link to the Audio Jungle website where you have gotten some of your clips.
Yeah, I'm looking at that now. Well, things may have changed. There are a lot of clips for like $1, but I think when you search, if you search for the exact sound you're looking for instead of choosing sound effects or music, sometimes that the search criteria might make a difference. But the way I'm looking at it now too, I'm seeing that there's not as many free ones. Maybe that website has changed. I'll look for one of the other websites, because there's a ton of free sound effects out there. So.
And you could always record your own,
Yes.
record in the kitchen yourself, boiling water or finding your pot. So there's an opportunity for kids to get involved on that end as well.
And we've done that with story building, where the kids are recording themselves reading the beginning, middle, and end of stories. And then they build their program with their own voice on there, which they love.
Oh, SoundStripe.
Yes, I use SoundStripe, and then also SoundSnap.
All right, well, without any further questions, let's take a look at the poll. When do you start engaging students in conversation about careers in STEM or just career educations in general? 33% chose early elementary, 24% chose late elementary, 29% said high school, and 27% said middle school, and 14% said high school. So I'm going to end that poll. Turn it back over to our presenters.
Great, thank you. I think those are interesting, interesting poll answers, because early elementary, thinking about our kids are doing dress up. They're saying, when I want to grow up, I'm going to be a firefighter, or I'm going to be a teacher, and all these different things, and encouraging those thought processes of yes, I can is great. And being computer scientists and the more engagement. So that's pretty wonderful. All right. So now let's talk careers. That's a big area of the ECC, because at the end of the day, what we're trying to do as teachers and parents and everyone is helping our students become the best version of themselves possible, whatever that looks like, whatever career path that takes them, whatever job path. So, but let's talk a little bit about STEM careers and computer science. I got this data was from the Bureau of Labor Statistics, but code.org has so many great resources around computing, computer science, and careers. So 67% of all new jobs in science, technology, engineering, mathematics are in computing, 67%. But the discrepancy is only 11% of STEM bachelor's degrees are in computer science. There's a huge discrepancy between what's needed in the world and what people are going to school for. So thinking about where the jobs are, that's something that we need to think about, because I know a lot of our students will be brilliant computer scientists in whatever capacity, from help desk to a coder to a developer to to a seller, to a technological seller. There's so many different areas of careers that you could have in computer science. Okay, so now another statistic. So computing jobs, think about that. Computing jobs are the #1 source of new wages in the United States. So 16.3% of the new wage jobs are in computing. And I have this big wheel on the screen, and it has all the different areas. Like transportation is 3.2, education is 4.2, business is only 8.5. There's all these different areas, but the biggest chunk of the pie is computing. So there are a lot of jobs available. There are 500,000 jobs, current job openings, every industry, every state, and it's going to grow twice the rate as other jobs. That's not saying going to go work for a giant tech firm. That might be going to work for a little mom and pop shop and being their IT person. That might be being a web designer. That might be being an assistive tech person. Computer science and computing jobs range across the field, and it's growing more and more every day. So let's kind of circle back before we finish. We saw a slide early on that Beth showed us that says, yes, I can. That metacognitive thinking about what are my abilities, what am I good at, and what do I need help in? Creating that mindset in the younger ages and seeing themselves as computer scientists. Again, experiencing, creating excitement, and this is something I can do. So that meter of I can't, I'll try, I will. If we go through all these processes and helping our students understand from a younger age through the ECC, all those different living skills, compensatory skills, everything, and helping our kids really understand that, hey, this is something I can do. I can pursue this. I have the abilities, because yes, I can. I know I can do this. We have the opportunity to give these students these incredible experiences to help them understand from a young age that this is something I can do, and not try to change that mindset when they get to middle and high school of, yes, this is something I can do. So really at the end of the day, CodeJumper is more than just computer science, more than just building programs. It's helping our kids understand that they are capable, that they are amazing, and that this is something they can do for the rest of their life if they choose. So with that, this is really what we have for our session, and I hope you enjoyed learning how to make pasta. You made a pizza today, so pretty fantastic. And just remember that not only our students can, but yes, you can too. So there we go. Thank you so much. So I'll turn it back to Paul and Betsy Ann.
All right.
Any questions before we go into our discoveries, Betsy Ann?
I'm not seeing any before we go into our discoveries. Let me get my screen share up and running.
Oh, I'll stop sharing.
Great, thank you.
I knew I needed to do something.
All right, so I think we've got discoveries up on the screen now.
All right, perfect. So let's talk about what we've discovered today. So we've discovered that CodeJumper enables students to learn computer science alongside other core subjects, that all students can benefit from CodeJumper because it's an inclusive coding tool. It can engage all kinds of learners. And yes, that means all age groups, not just the youngest, but high school students, adults. We've had people come to us that were adults that were fascinated by CodeJumper. The earlier you begin discussing career opportunities with your students, the more students understand what's available to them. That's so important. As someone who's blind, you definitely need to be told at a young age about you can instead of the things that you can't do. Engaging in computer science goes beyond coding. There's puzzles, reflection, unplugged activities. They all enforce key concepts, and they're all part of the Code Jumper curriculum in one way or another. So let's talk briefly about Code Jumper. If you're looking at it and you want to make a quota purchase of it, the price is $769. If you're purchasing as a non-quota customer, the price is $999. Codejumper.org is really a great place to go to see what the lessons are like, get an idea of the curriculum. If you're just kind of want to browse around and see what you can do, what's involved for the students, what kind of things they're asked to do, and how you can help with that and facilitate those things, go visit codejumper.org, get an idea about these things. Soon, as Robin said, the puzzles will be up there. They are fun. I've gotten to take a look at some of them, and they're fun, and lots of different ways to go through and learn all this stuff. And everything on codejumper.org, to answer the question, is free. There is no charge for the curriculum, just for Code Jumper itself. So have fun, go explore, and we hope that this has been helpful to you. We have more of these coming up, and we can talk about that briefly. If anyone knows the date of the next one, I don't remember what it is, but I do think we have another one coming up here shortly.
No date for that August one just yet, but we did have a question come in. Is Code Jumper able to change languages?
So my question about your question, is it languages of the computing language, or the spoken language? Because right now the sound sets, most of them are not words, but they are sounds, but the titles are in English, but all the content on codejumper.org is in English, but I think there are translations either in the works, or I'm not exactly sure, but I wasn't sure exactly what language you're referring to. So I hope that helps.
What part? Because you could make a sound set in another language as well.
Mm-hmm.
Right. So the text on the screen of the Code Jumper app will be in English, but yes, you could have foreign languages used as part of your sound sets. And of course, many of our sound sets are, car engine starting sounds and explosion sounds that would work for students who speak a variety of languages.
Absolutely.
And again, yes, head to codejumper.com and then visit us on the APH product page. I've posted those links in the chat to learn more about Code Jumper. As Paul said, while Code Jumper does come with a cost, all of the resources are free. So as we introduce lesson plans and puzzles, those are available on those websites. So keep a lookout for those puzzles. They're not available just yet, but they'll be available very, very soon. So thanks to Robin and Beth for joining us today.